Okay, so here we go. So you may want your calculator out to work on these, or I'm not going to plug these in the calculator for you. I'm just going to talk you through them, how you would find everything according to our equations. If you want them in your calculator, you need to be in radian mode, and you need to be in polar graphing form, right? You need to be in both of those, especially radians, because we're about to get into some rads. You know, normally it doesn't really matter unless you're Daisy, because hers matters, but everyone else's, but you do need it for this. So here we go. Okay, let me get all focused. So example 1, transform the polar equation to a rectangular equation. That's basically what it's saying. Then identify the graph and the equation. Okay, so first of all, this doesn't even look like a polar equation. This just looks like I gave you a theta. Well, I did, but what you didn't know all semester is that anytime you were given an angle in rads, that was actually a polar equation. It was a polar equation of a line, okay? So again, you're on a need to know basis, so now you get to know that this is actually a line equation. Okay, and also if you look up here and you try to match it with one of these fancy little shapes, there's no match. That's how you know it's not a fancy little shape, it's gonna be a line. Okay, so but here we go. So let's go ahead and start switching it over. We want to get rid of theta, and we want to get rid of any radian measure, and we want to turn it into just x's and y's. So I've put our 4 little possible equations over there on the end, and if you kind of look over those, there's 3 that involve theta, but 2 of those that involve theta also have an r involved. And I don't have an r. Now I could multiply both sides by r, but then I have an r times an angle, which just seems to complicate things. But if I look, if I had tan theta, that would give me y and x. So I can take the tangent of both sides. If I take the tangent, I'm just applying a function to both sides. That's what I end up with. Come on, camera. Focus, there we go. Okay, then that's what I end up with. That's perfect because I know the answer to each of these sides in terms of y and x. So again, you can do anything to the equation as long as you do it to both sides. So I know tangent theta, it equals y over x. That's one of my formulas. And that just got rid of theta. Okay, over here, I want to get rid of tangent and I want to get rid of this angle measure. Well, that's where this comes in. So if I look up tangent of 11 pi over 6, here's 11 pi over 6. Here's my y, here's my x. So tangent of 11 pi over 6 is going to be -1 over root of 3 over 2. And that just came right off the unit circle. Okay. Now I'm going to clean it up a little bit. So I'm going to have y over x. These 2's are going to cancel. I'm going to get -1 over the root of 3, which you know we rationalize. So this is going to be negative root of 3 over 3. Okay, we're not quite cleaned up yet. We have y over x equals negative root of 3 over 3. Okay, when they want a rectangular equation, they want y equals, right? That's kind of standard for algebra equations. So if all I want over here is a y, yeah, I'm going to multiply x on each side, and I'm going to get y equals negative root of 3 over 3 x. And here we go. That's going to be my rectangular equation. So just checking my text. Okay, so there we go. We took the tangent of both sides. We used the formula on the left, the unit circle on the right. We cleaned it up. All right, now you're also going to have to identify a graph. So this is definitely a line. I don't know if you're familiar, this is just kind of a side note, with this line. That's kind of a rock star line when it comes to algebra. This line is just a straight line that cuts diagonal through the first and the third quadrant. If your coefficient in front of x is positive, this is your line. If your coefficient in front of x is negative, it's just going to reflect over the y-axis. So if you notice, my coefficient in front of x is negative. So this line that you're looking for looks like that. And all you're going to have to do is identify that graph. It just flip-flops it, okay? The only difference is the reflection and then the slope is different, but you don't have to graph it yourself. Okay, is everybody okay with that? Okay, let's try one more of those. All right, let's look at example 2. Okay, here we go. I see the same situation. So in my mind, I'm thinking, okay, this is a line. Let's just get it switched over. All right, so again, our step was in this situation, when theta equals an angle, we're going to take the tangent of both sides. So if you need to make that note somewhere, that in this case, when theta equals an angle measure, take the tangent of both sides. That's the key. Okay, this is going to be y over x. This is going to come right off the unit circle. Okay, now I'm looking for 5 pi over 4. Here we go. All right, remember tangent is y over x. Just so happens these are exactly the same. So what is negative root of 2 over 2 divided by negative root of 2 over 2? 1. I'm just going to go ahead and put 1. If you need to fill in the inside there with the negative root of 2 over 2, just so that you don't get confused, you can. All right, we don't want to leave this like this. We want y equals, we're going to get y equals 1x, or actually just x. And then because it has a positive coefficient in front, there's our graph. Okay. All right, let's look at 2 other line situations before we get into these more complicated numbers or pictures. Okay, example 3 and 4. These are super easy. These are either a horizontal or vertical line. Let's look at how we know that. Okay, well, if we look at these guys and we look back at our little chart here and we try to compare their equation with one of these equations, we know it's not r squared, so we know it's not a lemniscate, okay? Let's see, we don't have a number added or subtracted, so it's not a limousin. It's not going to be, there's no number in front of theta other than a 1, so it's not a rose, which leaves us with just a circle. Now your circles look like this. Those are your circle choices. The problem is that's not what this is. I know you see an R and I know you see like a sine theta, but you have to have R by itself equaling a sine theta, which means you would have to divide both sides by sine. If you divide by a sine and sine is in the denominator, what does that become? Cosecant, right? And there's no cosecant. Same thing here. If you divide by cosine, this is going to become secant over here, not a circle. So that's how you know these are not circles. Circles have to be R equals sine or cosine. The sine and cosine can't be on the same side as the R. So these are lines. Here's what we're going to do. If you look at our 4 choices over there, can I replace R sine theta with something really easy? Yeah, what is it? Y. There's my rectangular equation. He's just a horizontal line. That's it. And so to pick him out, you would just hop up 5. There's your answer right there. He's a horizontal line. Okay, same situation down here. You look and see, do you see an R cosine theta? That's really easy to see. Yeah, he's X. Turns out that little guy is just a vertical line. So if you wanted to graph him, you're going to go 4 places to the left because he's a -4. And there's his graph. Okay, so the lines are pretty easy to see. They're not part of the little package that I gave you to look for. And they're pretty easy to replace with your X's and Y's. You don't have to do a whole lot. Okay. All right. Let's look at some that are kind of wonky. Okay, here we go. Oh, and by the way, that was, let's see, I told you example 1 was number 2 on my math lab. example 2 was just an extra. And then example 3 was number 3 and example 4 was number 4. And now these are just going to follow along the rest of them. 5 will be 5, 6 will be 6, all the way to the end on this. Okay. All right, so here we go. Now it tells us this is a polar equation. We knew that. We want to transform it to a rectangular equation. That's what they're asking for. Even though it says rectangular coordinates, they want the rectangular equation. Then identify and graph the equation. Okay, well, when I look at this, it doesn't look like any of those line options I had. He looks a whole lot like, from our little graph over here, I'm sorry, not X, R, my bad. Okay, from our little chart over here, he looks a whole lot like this guy. R equals A cosine theta. Does everybody kind of agree with that? This form that you see here looks just like this form here. They both have an R, they both have an A, a number here, and then they both have cosine theta. Okay, well, remember, A, your number that's out here, this is A, all right, that's going to be, well, we have to pull out a, hold on. I think I might have this problem wrong in here. What did I do? Oh, it's R, no, what did I do? Hold on, I got weird on them. This is written wrong in here. Oh my gosh. Okay, flip over here to page, whatever this page with your little chart is. Your book forgot a 2 here. That's crazy. I've never noticed that in all the years we've been using this book. This should have a 2 here. It should be 2A cosine theta and 2A sine theta. We already talked about it when we did it before, but on this little chart here, it's not here. Okay, so this is going to be 2A sine theta. Okay, so A is our radius. So in order to find our radius, I'm going to have to take this -6, which is equal to 2A, right? And pull out that 2. So my -6 is 2A. I'm going to divide both sides by 2. And I get a -3. Now we know that a radius is actually a distance, right? And so when we go to tell our radius, we're just going to say that it's 3. But when we go to give the center of our circle, that's when we're going to use our negative, okay? So let's think about this. Our function involved here is cosine. So is our circle sitting on the x-axis or is our circle sitting on the y-axis? X, because cosine is always involved with x. So that means that's going to be our center. Now you can put this right into your calculator, right? And you can graph it right away and it'll show you. But what we expect to find is the center of a circle over here at -3, 0. And then we expect to have a radius of this circle of 3, which is going to put us like this, right? It's 3 out in every direction. 3, 3, 3, 3. And we have a nice little circle, okay? So remember, when you change these circles to a rectangular equation, you have 2 choices. You can do this approach that we just did using our knowledge of circles, and you can graph it and zoom right in on your center if you want to, and you know your radius, you can count right on your graphing screen. Our rectangular equation for a circle is this. Okay, that's what we're going to have to write is our rectangular equation of this circle. Is it locked again? He did that on purpose, so you would get up and pay attention to him. Will you hit unlock on that? It's unlocked. I don't think so. There. Thank you, Elizabeth. Ish, you just want Elizabeth to get out. Okay. All right. So if and remember your center is HK. So if I were to write my rectangular equation, it's going to be x minus -3, that's a plus 3 squared, plus y minus 0 squared equals my radius squared, which is going to be 9. So if I clean it up a little bit, this is going to be the equation for this circle. Okay. Now we have our equation and we have our graph and we're done. And we didn't actually do any algebra. Everybody see that? We just stuck with graphing and we figured it out from the basic equation there. Now, I just want to show you one more time. We won't do it on number 6, but I want to show you one more time that you can get there the same way without having to remember any of this, right? We can get here the same way if we go through using our formulas and then we have to complete the square. Most students don't choose to do that because there's so many ways you can mess up, but that's kind of what it was intended. You're supposed to do it that way. I just think it's kind of a waste of time. But anyway, let's say we start with this guy here. All right. If I'm starting with this guy here and I want to change into X and Y's and I don't remember this formula and I don't know any of this information, I'm going to multiply both sides by R. So R times R is R squared. I'm going to throw an R right here between the -6 and cosine. Okay, I just multiplied both sides by R. Now I'm going to go over to my formulas and replace anything that I see. So I know R squared is X squared plus Y squared. And I know R cosine theta is X. Okay. Now I'm going to move my 6X to the other side. So I'm going to add him over and I'm going to sit him right next to his other X term. And I'm going to leave a blank. Okay. And I'm going to leave a blank on this other side. This other side is like 0 plus something, right? Let me just go ahead and maybe you need another step there. I don't know. Okay. So I added him over. Okay. Then I'm going to sit these two next to each other and I'm going to leave a blank because we have to complete the square. Then I don't have to complete the square for Y squared because he doesn't have a single Y term. That's why it's not necessary for him. And then over here, I just have a 0. So I'm just going to throw this blank over here. Okay, I got a blank on each side. All right, remember, when you complete the square, you're looking at B divided by 2 squared. So my B is 6. 6 divided by 2, 3. Squared is 9. I'm going to add a 9 to both sides. Okay. Now I'm able to factor that because he's a PST. So I'm going to take square root of the first term, square or sine of the middle, square root of the last. And there's my equation. It's the same equation I came up with by just using my knowledge of the polar equation. So it's up to you how you get it. Doesn't matter to me. Just make sure you can get this equation, whether you complete the square or you graph it and kind of mess around and find your points. In that case, you'd have to know your standard circle. All right, let's do this one down here. Let's just get you started on it because it's a little strange. Okay, so here I want to do the same thing. Does anybody have any questions on number 5 on how you can pick and choose how you want to do that? Okay, let's look at example 6 then. All right, so look at this guy. At first glance, you might go, okay, no, this isn't even possible because it's got cosecant and there's no cosecant anywhere. This is a reciprocal function. Well, let's change cosecant to his reciprocal function. What is cosecant equal to? 1 over sine. Okay. Then let's move our sine to the other side because I notice when I go back and look at my circles that this is a circle, right? So if I multiply both sides by sine theta, I get R equals 2 sine theta. That's a circle. Okay, so sometimes you're going to have to change that reciprocal function so you know to scoot it over. All right, now I need to find my radius. So I'm going to set 2 equals 2 to equal to 2a, divide by 2, and what's my radius going to equal? 1. Okay, so I have a radius of 1. Let's figure out my center. Okay, I'm looking at sine. So is my circle going to be sitting on the x-axis or the y-axis? Y-axis. Okay, And since my radius is a 1 and I'm sitting on the y-axis, he's going to be 0, 1 is my center. Okay. Then I can use that formula from up here to write my formula. So I have x minus 0, that's my h, plus y minus k, that's 1, equals my radius squared. So my final answer, all cleaned up, is just going to be that guy. Now remember, you could have started back right here at this point and multiplied both sides by r, then changed this side to x squared plus y squared and changed this side to 2y. Then moved your 2y and completed the square for y, and you would have come up with the same thing. Okay, now let's go ahead and graph him. We know that the center is going to be 0, 1. There's my center. And my radius is 1. So he's a little tiny and he's sitting right there. And if you graph this version, don't graph the one with the reciprocal, graph him. That's what you'll come up with. And then you know that it's right. Okay. Is everybody okay on that? Okay, that's pretty much it for circles. All right, so we did lines and circles. All right, let's check out some limacons. Okay. All right, 7 and 8. Limacons. Okay, so if we go back to our little chart here, okay, and I'm looking at this equation, I'm looking for r equals, so it is not going to be a limnoscape because those are r squared. Okay, and I notice I do not have a number in front of theta, so it can't be a rose. And I notice I have a number in front of that's been added or subtracted to this, sine theta situation. That means we're looking at a limason. It's got to be a limason. Now, you can graph this right in your calculator and you know exactly what it is. That's why I showed you how to do it, right? You can see what it is. Okay, so if we look up the formula for a limason that has sine in front of it, then you're going to get a minus b sine theta, okay? The sine here and the minus here means it's going to be facing which direction? Down. Facing down. With a sine, it's got to be up or down. With the minus, it's going to be down, okay? Now we just need to compare A and B. Well, my A is 9 and my B is 9. So if I make a nice little ratio, just like this, I get a 1. And if you recall, if your ratio is equal to 1, you have a cardioid. Remember, that's the little butt. That's the sharp little butt that goes inside there. Okay, so what I would expect to see then from my graph, all right, is just, let's see, I'm facing down. You're going to have a nice little butt that faces right down like that. And there you go. Okay. And I'm looking here. I know I have identify the polar, identify and graph the polar equation. Okay. So all they're going to want to know from you, you do not have to change these to rectangular because other than a circle and a line, you can't change to rectangular. That's why you've never heard of limacons. That's why you've never heard of limnoscapes. That's why you've never heard of roses or Archimedes spiral, because you can't turn them into rectangular. There's no way to contain those. You guys know there's some expressions in Spanish that just don't translate to English. And there's some expressions in English that just don't translate the other way. Same thing with planes. There's some things in rectangular that just don't translate to polar and backwards the other way. So you don't have to do these. You only have to do lines and circles. But you will have to say it's a limason, and you will have to say that it's a cardioid. Okay, so you can tell those two things by simply graphing it, or you can use the formula, do the ratio of A and B. That's how you know it's a cardioid, is this ratio. And you know it's a limason based on this. And you know it's facing down because it's sine with a minus. Okay. So that's kind of how you're going to identify all that good stuff. Is that okay with everybody? Okay. All right, let's try our next one. Okay, I have another limason. I know that because I have a number in the front that's been added or subtracted. So it's got to be a limason. Okay, I also notice I have cosine. So now I'm either left or right, right? I'm on the x-axis. And I have a minus. Now remember, it's not like a transformation where the minus means the opposite of what you think it would, right? It's true. Looking at it, it's a negative x. So this is going to face left. All right. And then we notice that our A is 20 and our B is 10. We're not worried about the signs. You don't put the negative in. You're just taking the absolute value of those numbers. That's going to be 2. Okay. So now what we're going to do is go back and look at our little chart here. What do we do with a 2? Well, if it's less than 2, we have a dimpled cardioid. If it's equal or greater than 2, we just have no inner loop. And because this 2 is equal or greater than 2, it's equal to, we have no inner loop. So we're gonna, you could graph it, but we're gonna expect our graph, it's gonna be kind of circular, kind of oval, kind of in the middle, okay? And it's going to be facing left with no inner loop. So it's gonna kind of be like this, kind of off center, kind of facing toward the left. All right. Now, I'm starting to come back to me what this my math lab looks like. So it's going to be multiple choice that they ask you. So what they're going to say, let's go back up to number 7 for a minute. Remember, in the rectangular coordinates, this is the x-axis, this is the y-axis. In polar coordinates, this is pi over 2, and this is the polar axis. Okay, so when it says facing down, this is going to be pi over 2. Okay, facing down, it's not going to say y-axis to you. And here, when it says facing left, it's going to be facing left on polar axis. Okay, so make sure you realize x is polar axis, y is pi over 2. Okay, almost done. All right, here we go. Again, you can just simply graph this guy if you want to, but let's go back and think about it. We're supposed to be thinking about it here. First thing I notice is I have a number in front of theta. Haven't seen that before today anyway, right? Okay, that means if you have a number in front of theta, you have a rose. Okay, that's your graph, you have a rose. So in this case, because I have cosine, I'm gonna have a cosine in theta. That's my formula. All right. Okay, so remember, here's your A, here's your N. So A equals your petal length. So you're going to have a petal length of 7 units. They're going to ask you, what's your petal length? You're going to have to type in a 7, okay? Then they're going to ask you how many petals. They want to know the number of petals. Now remember, that's not always equal to n. You use n, but it's not always equal. If n is odd, that's how many petals you got. If n is even, what do you have to do to the n? Multiply it by 2. Okay, so in this case, my n equals 2. So I don't have 2 petals. How many petals do I have? 4. Okay, so I have 4 petals. All right, if you want even more information, like what is your petal spacing? Remember, it's going to be 360 degrees divided by how many petals you have. You're expecting a 90-degree spacing. You're going to have a cross. Now, again, you can just graph this and figure out what it looks like, but what you're expecting is that guy, okay? A nice little cross. Mine got kind of fat and weird, but that's, you know, what you're looking at. Oh, and it's out of focus for my people on Zoom. Okay. All right, here we go. Now let's look at the next one. Okay, again, I see a number here, so I'm a rose. So I should have put that up here. Rose, okay. I'm a rose. All right. So now I see sine. Sine and cosine with the rose, it's really kind of hard to predict what it's going to look like. It doesn't give you a whole lot of information. It just depends on how many petals you have. So I wouldn't get caught up with that. But here we go. My A is 2 and my N is 5. Okay. So this looks a whole lot like the sine version. Okay. So again, my A is petal length. So when they ask you that, you're going to put a 2. This is a teeny tiny little rose. Okay. Now, when it wants the number of petals, though, how many petals do I have? 5. I have 5. My N is 5, and since that's odd, that's also how many petals I have. Okay. All right. Oh, and then if we wanted spacing, 360 divided by 5, I mean, that doesn't really help me. That's 72 degrees apart. Okay, so I will go ahead and tell you what that looks like, but you could always graph it. You're going to have a little one on top, a little one diagonal in each quadrant. Okay, it's kind of pitiful looking, but that's what's supposed to be only really pretty. It's a starfish. If you put it on your little card. What do you mean? You put it in your calculator, it'll make that picture. You can just put like rose is this and this, you know. Yeah. That's why I showed you the calculator. I know. You went and bettered your future, but it's on video. No, it's not on video. You don't know. You'll never know. Okay. All right. All right, here we go. So now we want to identify the graph, and I see something that gives it away right there, r squared. When you have an r squared, you have a lemniscate. Remember, a lemniscate's an infinity sign. Infinity signs always have 2 petals. Okay, so if you go back to your little chart and you look for a lemniscate, you look for r squared, here we go, right here. And if I write it over, it's going to be a squared cosine 2 theta. Okay. This cosine means that I'm going to be horizontal. My infinity sign is going to sit on the x-axis or the polar axis, right? If it were sine, it sits kind of diagonal, like that y equals x line. Okay, the only thing it's going to want from you here is the petal length. Remember, your petal length is a, but a lemniscate gives you a squared. So your petal length is not 81, it's 9. And then if you were to draw it, he's gonna look like that. Yeah, sitting right there. Okay, now remember, if you were to put him in your calculator, you're gonna wanna put the positive square root of the whole thing and the negative square root of the whole thing. Don't try to take the square root first. Don't put 9 out there in front. Just take the square root of the whole thing and the negative square root of the whole thing. Remember, then you kind of have to fill it in with your imagination so that you kind of remember it. All right, brings us to our very last shape. Okay, here we have an r equals some kind of coefficient of theta. When you see this and you see an r and you see a theta, but you don't see any sines or cosines, this is your spiral of Archimedes. Okay, and all you're going to have to do is identify it, because there's really no information to get off here. Spiral of Archimedes always starts in the center, and then it spirals through each quadrant in order. And then off it goes. Okay, and you're good. Sound good? That's 9 too. And you can always put him right in your calculator if you want to. Sure. Okay. So you don't have a sine or cosine, you just have a theta. So your picture, he starts at the origin and he goes through every quadrant in order. So he starts here and he just spirals right out, and then you'll know it's right. Kiddo? Well, it just has to look like that. It can't look like this. It can't, be anything wrong. It has to look like that. It's not that one. Okay, sound good? All right, we're gonna hit 9-3. Okay, so we're gonna kind of leave the polar plane. Remember, we're leveling up into your different world. We did rectangular, we did polar. Now we're gonna be in complex. We're headed to complex plane. Okay, so this complex plane says vector representations. A vector is like a line with an arrow, like a ray. We're not going to get into rays or vectors in this section. I know that there's one right here staring at you, but just ignore him. We're going to save vectors for another section. So here's what your complex plane looks like. Okay, your horizontal axis, which would normally be the x-axis, is going to be called the real axis. Okay, that's your x-axis is now called the real axis. All right, the vertical axis, that's your y-axis, is now called the imaginary axis. This is my math lab number 2 for this section. Okay. Now you can graph complex numbers right here in this little section. So if you remember from algebra, a complex number has a real part and imaginary part. Remember that? A plus BI, you got a real part and an imaginary part. Okay, well, here we go. What if I wanted to graph, and it already did it for you, 2 minus 3i? Okay, we actually don't want that arrow. We don't want that vector. Instead, I just want to put a point there, just like that. Okay, so on my math lab, they're going to give you a graph, and then they're going to have you graph this. And there's not going to be like a little tool like you normally use for a line or a parabola or anything. You're just going to take your little cursor, your little mouse, and just click on wherever you think it should be, and a dot will appear. That's all you got to do. Okay. So for 2 minus 3i, my real part is 2. My imaginary part is -3. And that's all I'm going to graph. It looks a whole lot like x and y. So I go +2, -3. There's my point. And don't worry about drawing a line to it. Okay, we'll draw lines another section. Okay, so here's where it gets a little bit tricky for you. You're going to learn some things you haven't seen before, so it's going to be a little foreign, and things always seem harder when you haven't seen them, even if they're not. So with these complex numbers, for example, with this, for example, you are going to have to write that in 3 different ways. You're going to have to write it in rectangular form. You're going to have to write it in polar form, which we actually call trig form. So you may just see directions say write it in trig form. That means polar form, because if you've noticed, you've been living in the r theta polar world for a while. You just didn't know it. And then sometimes it'll tell you to write it in exponential form. So you have to be able to hop back and forth between these 3 forms, okay? All right, so anytime we're in the complex plane, anytime we're dealing with complex numbers, we don't have r equals and we don't have y equals, we have z equals. We're introducing a new letter. So when you see z, you know you're in the complex plane. You're gonna have a real part and an imaginary part, okay? So if they ask you to write a complex number in rectangular form, you're going to be z equals x plus yi. So this one we could write over as 2 minus 3i. That would be his rectangular form. Now I can't give you examples for these 2 until we go on to do it, because it's too difficult to try to go back the other way, okay? All right, but let's talk about polar form. So you know in polar form, you need 2 things, right? Rectangular form needed x and y. We incorporated that. polar form or trig form needs r and theta. We need to incorporate that. So here's the deal. This is what polar form looks like, is that guy right there. I want you to scribble out this z equals here. I shouldn't have put that there, okay? This is your polar form. You can also write it as this. So let's think about where I got that from. Here's my r, that makes sense. But suddenly I took cosine theta plus I sine theta and I turned it into cis theta. Where'd I get the word cis? Okay, it's just an abbreviation of cosine imaginary sine. Look, C-I-S. It's just an abbreviation. So if you're lazy and you don't want to write all this out, you can just write that. And it's the same thing, okay? Now, let's just remember how we went from rectangular to polar. If you look down there at our formulas, x equals r cosine theta. Well, there it is if you distribute the r. Y equals r sine theta. Well, that would be right here if you distribute the r, but they always put the I in front. They don't like the I in the back because when you put the I next to the theta, it looks like it's part of the angle and it gets confusing. So they just move the I to the front. Okay, but that's where this came from. Because if I were to just do r cosine theta plus, move my I, r sine theta, that's the same thing. Everybody agree with that? We just replace the x and the y. And then all I did was pull the r out down here. And that's how I came up with this. And then if you don't want to write all this, you can just write C-I-S. And there you go. Okay. All right. The very last form is exponential form. So you guys may not know this. I don't know. I know I don't mention it in college algebra. A lot of y'all had this Culligan, but you know that little number E, the little E that's on your calculator? It's like 2.17, blah, blah, blah. Okay. That's actually called, the reason he's an E is he's Euler's number. Okay. He's Euler's number. This guy Euler, that is the father of geometry and trig, he came up with that little e and named it. So exponential form involves e. And so sometimes they call exponential form Euler's formula. Sometimes you'll see that, okay? All that means is that exponential form is that instead of, is that e to the I theta equals this. So all we're going to do is replace this part with e to the I theta. This is exponential form. Z, there's your r, but we replaced the cis theta with e to the I theta. Okay, so basically you replaced cosine sine with e. That's all you did. And you put the I and the theta up in the top. All right, I know that's a lot of new stuff to throw at you, but you're going to get in the groove of it and it's going to seem a lot easier. Okay, we're going to keep on keeping on. So in polar plane, okay, polar form, r is your radius. In complex plane, we call r the modulus or the magnitude. And that's going to come into play when we get into vectors, okay? Angle theta is called the argument. So this is number 3 on my math lab. R is your modulus or magnitude. Theta is your argument. Okay. And so one of the ways that we can find the magnitude of Z is by using this little formula. Square root of x squared plus y squared. You may remember him from pre-calc. That's number 4. Okay. All right. So let's keep going through some formulas here. I know these formulas are kind of wacky. We're going to get to examples in a minute and it's going to be a little nicer for you. Okay. So let's say that we take this x plus yi. Here he is right here on the left. X plus yi. And then let's substitute for x let's put r cosine theta, okay? And then let's substitute for y r sine theta. There's our I. We move our I to the front. That's where we come up with the r cis theta. And I kind of already did that for you up here. So they just walk you through it. So the polar form or trig form of a complex number is this guy. And that's the really important takeaway from this section. Now the next page we're going to hold off on. We're going to do some examples that involve this and get a really good handle on it, because the next page is a little too much to throw at you right now at this point. We need to get comfortable using all these different, oh, I don't even have it on your next page. Oh, good. The way that I used to do it is to throw it at you right away, and it's a little much and kids would freak out. So good, that worked out well. Sometimes I even surprise myself with my planning here. Okay, so we've done 2, 3, and 4 for my math lab. You're finally on to number 1, and then this picks back up with number 5. Okay, so number 1 is good old algebra. So if this is your complex number, 9 plus 5i, anybody remember how to find the complex conjugate? 9 minus 5i. So what did you change? The sign of the imaginary only. Okay, we do not want to change the sign of the real number, correct? So what if, let's just throw this over here, we had -3 minus 5i. What would his complex conjugate be? -3 plus 5i. Always leave the real alone, only change the imaginary for your complex conjugate. Good. Okay, that brings us to number 5. Okay, we're going to do everything for number 5. We're going to plot our complex number. We're going to write it in polar form, and we're going to write it in exponential form. We're going to do everything we just learned, okay? Because as it turns out, this guy right here is already written in rectangular form. That's rectangular form. He's done. Your X is 9, your Y is 9, there's an I on the end. So that's why we're not putting him in rectangular, because he already is. All right, so my real portion, that's your x-axis, is a +9. Here we go. Your imaginary portion, that's over there by your I, is a +9. Goes up. There we go, I graphed them. That's all you got to do. So on my math lab, you're just going to click right on that little point. It'll put a dot there and you move on. That's it. Okay, what quadrant is that in, by the way? Quadrant 1. Always a good idea to keep that in mind for later. Okay, so we did it. Here's your real part. Here's your imaginary part. Okay, good deal. Okay, now let's come down here. It says simplify your answer. Okay, it tells you all kinds of things. Type an exact answer, use pi if you need it, make sure your angle's in radians. You want to be between 0 and 2 pi, fractions only, no decimals, all that good stuff. Okay, so here we go. We have now, if we were to flip back, let me flip back. Okay, we have this nice little, let's do it this way. Okay. What we're trying to get to is either this, well, I don't have it on here, do I? Okay, let me fix it then. I just didn't circle it on here. Okay. For our polar form, we want to be this. Or you can just be r cis theta, right? We said that. And then for our exponential, we want to be this. That's our goal. Okay. And we already know that we have an x equals 9 and a y equals 9 from this rectangular form that we used up here. Okay, well, we have our formulas over there to kind of help us out over on the right. So the first thing I notice I'm going to need for either one is an r. Okay, well, if I have x and y, I can find r. I'm going to use my equation over there. but I'm going to solve it for just r. So I'm going to take the square root of both sides. So this is what I'm going to use to find r. And I'm going to have the square root of 9 squared plus 9 squared. It's 81 plus 81. That's the square root of 162. Okay, now you can play around with your 162 and see what you can pull out. You can actually pull out an 81. So if you reduce this, you're going to come up with 9 times the square root of 2. So I want you to be comfortable being able to reduce these. This is one of those sections where that little skill is going to come in really handy. Put that 162 in your calculator and see what the biggest square root is you can pull out. Okay, so it ends up it's 81 plus 81, so you can pull out an 81, right? 81 times 2 gives you 162. And then take the square root of 81, you get 9, you're left with the 2. All right, now I need a theta. Well, I know tan theta is y over x. Okay, so my y is 9, my x is 9. I know tan theta equals 1. All right, now remember, I had you go ahead and tell me what quadrant this point was in for a reason, because I need to find what is the theta where tangent equals 1 in quadrant 1. That quadrant where your point is in is going to give you your theta. So if I stay in quadrant 1, what is my theta going to be? Pi over 4, because y over x is going to give me 1. So my theta is going to have to be pi over 4. Okay. Is everybody comfortable with getting these two values here? This and this? Okay. Now all you're going to have to do is put them right in. You did the hard part. Now you're just going to put them in your formulas. Okay. So for my polar form, I'm going to have 9 root of 2 cosine of pi over 4 plus I sine of pi over 4. That's my polar form or my trig form. Now again, you can be lazy and it's perfectly acceptable to do 9 root of 2 cis pi over 4. That's the same thing, okay? Either one, if you'd rather not write out cosine theta plus I sine theta. Okay, now we also need exponential form. Exponential form is 9 root of 2 e to the I pi over 4. And as strange as that looks, that's exactly how you leave it. Don't stick the I behind the pi over 4 like a variable. Leave the I right in front, just like this, because remember, this is the form. And then you've got it. So it's very important that you remember what quadrant that you're in so that you can write that over. Okay? Is that good? Let's try another one of those. Okay. How about this guy? This guy's got some a little bit more difficult algebra happening here. Okay. All right. So here's my real portion. Here's my imaginary portion. Okay. So basically my x is going to be 12 root of 3 and my y is going to be negative 12, right? All right, now you have to graph this on an equation. This is where, I mean on a graph, and this is where it gets a little strange. You can find negative 12, no problem, except it's not on my graph. But what the heck is 12 root of 3? Okay, put it in your calculator. So if I put in 12 square root of 3 in my calculator, I get 20.78. I'm just going to round it. Everybody see that? Okay. So I'm just going to say he's kind of 20.78. Good enough. All right. Then when you go to put him and graph him, it's going to give you little decimals up here to kind of help you when you're on my math lab. But you'll just go out a positive 20.7, go down a negative 12, And let's just pretend he's down here. The important part to note is what quadrant is he in, right? So graph him the very, very best that you can. This would be the point that you're looking for, kind of taking note that this is whatever your calculator tells you. And it'll kind of give you a decimal approximation as you're scooting along there. And it should take it just fine. If you have a trouble though, take a screenshot and send it to me. All right, now let's rewrite this. Everybody good with that part? Okay, so we need an R. Remember, R is going to be square root of x squared plus y squared. Okay, again, this is just going to require a little bit of algebra. All right, you can put in your calculator 12 square root of 3, and you, oh, hold on, I got weird. 12 square root of 3, and you can square the whole thing. And then you don't even have to think about what it is. It tells you 432. Or 12 squared is 144. Root of 3 squared is 3. You're still going to get 432, however you choose to do it, okay? So I got a 432, negative 12 squared is 144. This is going to give me square root of 576. Before you panic and start trying to pull things out, check and see. If you take the square root of it, turns out it's a lovely little 24. He was a perfect square, okay? All right, there's our R. Only other thing we need is a theta. Okay, so my y is negative 12. My x is 12 root of 3. I'm going to get negative 1 over square root of 3. Now you can leave that if you want to, or you can rationalize it. I would just leave it because it's going to help your mind a little bit. You're not trying to find the answer to this. You're trying to find theta, right? So what I'm looking for is what is the value of theta where tangent equals this in quadrant 4, okay? So here's my unit circle. Here's quadrant 4. I only have 3 choices. And I want to be 1 over root of 3. That means I want my root of 3 to be in the bottom, which means he needs to be an x. So I think my theta is 11 pi over 6. Does everybody agree with that? That would make y over x. Okay, that would make negative 1/2 over root of 3 over 2. These cancel. That's going to give me a nice negative 1 over root of 3. So my theta is going to be 11 pi over 6. Okay, now all I have to do is put this stuff together. All right. Oh, I put R equals, I'm sorry. Z equals, bless you. All right, if we're going to write it out the long way, we're going to do R parenthesis cosine 11 pi over 6 plus I sine of 11 pi over 6. If you want the shortcut, you're going to do 24 cis 11 pi over 6. All right, let's do exponential form. Exponential form is R e to the I theta. And there you go. Okay, so it may look strange and foreign and complicated, but once you start doing it, it's not a big deal. You've been finding R and theta for a long time, and we're just doing it in sort of a different situation now. Okay. Let's see. I don't think we need to do, number, well, we got to stop anyway. Never mind. I don't think we need to do number 4, but we will start with number 5. We might do number 4 together when everybody gets back to make sure we're all on the same page. But